Hello, my name is Hana, and today we're going to discuss about math symbols, history behind it, and how it evolved to the symbols we know today. Okay, so first we're going to discuss what mathematic notations mean, because we're going to discuss it throughout the slideshow. So the definition of notation generally implies a set of well-defined representations of quantities and symbols operators. So the history includes many different cultures. The history includes Hindu Arabic numerals, letters from the Roman, the Greek, Hebrew, and German alphabets, and a host of symbols invented by mathematicians over past several centuries. So we're going to discuss quite a bit of cultures throughout this slideshow. So the main numerical images or finishes of paperwork from the portrayal of numbers, ciphers, the presence of which evidently went before the presentation of composed language. The most ancient framework of numbering are the Babylonian and the Egyptian, which date back to around 3500 BC. Ancient Greece had a huge role in the numerical images. So for the arbitrary quantities, they showed up a lot later in Greece. Arbitrary quantities were addressed by the lengths of lines, and such two quantities were represented by rectangles. So they had two perspectives or two sides of the rectangle. In the Euclid's elements, amounts were meant by two letters. So the initial and the final letters, which are comparing the portion, and some of the time by one letter dating from the Archimedes, which they last devised became the standard. Next we have the post-Hellenistic area. The fundamentals of letter documentation and math showed up in the post-Hellenistic period on account of the freedom of algebra from its geometrical settings. Diophantus meant the unknown x and its power by the following symbols which we now use, and we have here a picture that shows what Diophantus meant. So how did Diophantus write the coefficients? So he wrote the coefficients to the right of the unknown or its powers, and it was also denoted in uh, some Greek letters over here. The terms were added together by simply juxtaposed, while subtraction required a special symbol, also another Greek symbol. And also equality was denoted by this letter here. For example, Diophantus would have written this equation that we in the modern times write in these symbols. So for the Indian mathematics, so several centuries later, the Indians they developed, of course, numerical algebra. They also introduced different mathematical symbols for several unknowns, so abbreviations for names of colors, which denoted to the unknown, the square, the square root, and etc. So, for example, if a equation that we write now, and this is how in the notation they have written, it would have looked something like that. Last but not least, Islamic mathematics. So Islamic mathematics created and extended the math known as Central Asian civilizations. So, for example, the Indian mathematics. And Al-Khwarizmi gave a comprehensive clarification of logarithmic arrangement, quadratic conditions, positive roots, and Al-Khwarizmi was to show the polynomial math in an elementary structure for its own sake. Al-Khwarizmi likewise examined a crucial strategy for decrease and adjusting, eluding the interpretation of deduct terms to the opposite side of an equation. Here I have inserted three images. So I have inserted the ancient Egypt numbers, and as you see, they were more of stroke-like. And here I included the Greek symbols. Of course, we still use the Greek symbols like theta, alpha, and beta, and others. And here we have the ancient Indian numbers. Unfortunately, I was not able to put it on the Indian mathematics slide, but over here you can see how they looked like. We have made it to the end of the video. Thank you for watching, and these are the resources that I have used throughout the slideshow.